Hey, welcome back. Today we're looking at 3-1 functions. So the main thing to remember about functions, I know it's a little bit wordy explanation, but it says functions are relations in which each input has a predictable output. Um, when we're talking about functions, there's plenty different ways that we can look at them. Today we're going to be covering mapping, sets, and graphs. You can also look at equations and other things when we're talking about functions. So let's just kind of get into it. So the thing to remember is that each input has a predictable output. That means that if I am looking at a soda machine, when I put my money in and I press the button for the soda, I expect for that soda to come out. The machine would be broken. Like say I put in my $2 and I press the Pepsi button. I would expect for that machine to always give me a Pepsi if I press that button. Now, if I press that button on the same machine and Mountain Dew comes out, then it's no longer working properly and therefore it wouldn't be a function. So let's look at a mapping. So for this first one here, we have John, Mabel, and Kevin, and the outputs are favorite types of ice cream. So we have chocolate or mint. So let's say John likes chocolate, Kevin also likes chocolate, Mabel likes mint. Now, notice that John and Kevin are both going towards the output chocolate, and that's fine. That's still a function because John only goes to chocolate and Kevin only goes to chocolate. So if I asked you what is John's favorite ice cream flavor, you could tell me that it's definitely chocolate. So this is a function. The way we're doing this is the left-hand side will be a function, the right-hand side will be a non-function. So let's look at this example. So let's say this is well, I can't say a function, a relation between the people on the left-hand side, Wade, Scott, and Jean, and that the right-hand side is the types of pets they own. So let's say Wade owns a dog, and Scott owns a cat. So far, so good, right? Wade goes to dog, Scott goes to cat. Now let's say Jean, though, has a fish and a dog. This is no longer a function because Jean's output is a dog and a fish. So if I asked you what is Jean's pet, some people might say dog, some people might say fish, it depends, or she might say both, right? So this one is not a function because Jean has two outputs. Okay, now let's look at the set notation. So a set has these braces, and then we have points inside. So we have 3 points for each of these. Now notice that for our inputs are our x values. So we have inputs 1, 2, and 3, and then our outputs are y. So as long as we don't have the same x twice, right, we have 1, 2, 3, this is definitely a function. So no x twice. Now if we look at the second one, we have 1 going to 3, 2 going to 4, and then 1 going again to 7. So for the first and last point, because 1 has an output of 3 and then 1 has an output of 7, this is not a function, right? Because we have two x's with different outputs. Okay, so it goes back to the idea of a function. If I have an input, I should be able to predict what the output is going to be. Okay, so graphs, the vertical line test, it's very wordy, but it's really simple in practice. So it says if a vertical line cannot be drawn that passes through the graph more than once, then it is a function. So let's draw an example of a function. So it can be super curvy, right? And the vertical line test says that as long as I can't draw a vertical line passing through this graph more than once, then it's definitely a function. All right, so non-functions. Definitely a circle would not be a function because there's plenty places where we can draw vertical lines that cross through that more than once. Something that's shaped like this, again, does not pass the vertical line test. Be careful with the ones where we have points, right? Because some of these pass, but if you can find any point, you can draw a vertical line through. This doesn't pass a vertical line test. And also be careful about stuff like this. Anytime we overlap, that's going to not be a function. Okay, so the last thing, it's not really determining function or non-function, it's just evaluating. So this is kind of like Algebra 1 work. What it's asking us to do is find f of 2 and g of 3, and our functions are given. So all we're going to do is substitute into our x's. So for f of 2, we take our f of x. In place of our x, we're going to put a 2. And we're going to remember our order of operations. So we're going to do our exponent. 2 to the third is 8. And then remember we need to multiply. Negative 2 times 8 is negative 16. Plus 5, which is negative 11. Okay, similarly for the g of 3, we're going to be using g of x. We're replacing x with 3. So g of 3 is going to be equal to 4 times 3 minus 1. We're doing our multiplication first, following order of operations. 4 times 3 is 12. 12 minus 1 is 11. Alright, so that's it. It's pretty straightforward and easy today. Please let me know if you have any questions next class. We can go over it. Good job.